In this video, we're going to continue with the exercises. Okay, we start with question 24. I think it's similar with the example, so I will skip and move on to question number 25. Okay, find the moment about the origin of the force. So the question gave you in IJ form. So let's draw the diagram. So the moment would be here. Okay, so the nut or the pivot would be here. Of a force of 4J, the force is 4J and it is acting on the position vector. So we have negative 5. So in IJ form, I would be in the x axis. So let's say this is negative 5. So we have negative 5-point position vector here. So the force is 4J. So means that the force of 4J start from here. So J is in the vertical form. So 4J will be here. So the moment will be here. So we're going to find the moment. So the force is 4 and then the distance. Okay, this is perpendicular. So we have 5 here. So 5 Newton meter. And then if let's say it move here, so it is moving here. So it is clockwise. So your answer would be 20 Newton meter clockwise. Question number 27. Okay, let's say we go move on to question number 27. Okay, question 27, find the moment or about the origin, same as question 25, with a force of 4I plus 2J, which has a position vector of 3I, 2J. So it means that 3, 1, 2, 3, and then 1, 2, J. So we have a position vector here. Okay, and then start from 4I. So we have 4I and then we have 2J here. So find the moment about the origin. So if let's say this is origin. So first of all, 4 times with the distance. So distance should be, let's say this is the force. So the distance would be here. So this is, just now this is 3, right? This is 2, is it? Position vector 3, 2. So the distance would be 2. And then is it clockwise or anti-clockwise? So you move to the right, clockwise. Okay, and then plus with the another force. So another force is 2. And then the distance would be, let's say from here, so we have 3. Okay, and then it move up. So it is anti-clockwise. So anti-clockwise. So we get 8 minus 6 clockwise. So we get 2 Newton meter clockwise. Okay, we'll move on to question 29. Okay, question number 29. Okay, a force of 2I plus j and x at a point which has a position vector 2I plus 2j and a force 5in at the point which has a position vector of 2I plus j. Okay, find the sum of moment. Okay, so this question is also the same as the previous exercise. The only thing is more than one moment, so we need to find the sum of moment. Okay, we look at the first one. The position vector 2I, 2j. So if let's say we have 2, this is 2. So we have 2I plus 2j point. And then the force is 2I. Okay, and then j here. Okay, so we find this first, or else we will be confused. Okay, so the first one is the force is 2 and the distance, if let's say this is the origin, so the distance must be 90 degrees, so this would be also be 2. Okay, and then it, let's say it move here, so it will become clockwise. Okay, plus, and then we have 1 j. So the force would be, the distance would be 2 here. clockwise or anti-clockwise. So you move up, so move here, so it is anti-clockwise. Okay, this is the first one. Okay, second one is negative 2, because I don't want to confuse, so I will redraw another diagram here. So position vector is negative 2. So negative 2, let's say this is negative 2, and then we have 1G. So this is the point. Okay, and then the force is 5G. So let's say this is a straight line, 5G. Oh, sorry, 5G must for 5I. This should be 5I, so it's horizontal, so 5I. So this one you only have 1, right? So I just plus this here, 5. Okay, if let's say this is the origin, so the distance would be here. So the distance should be, this is just now, this is 1. So distance, this one is 1. So 1. So you move here, so it is clockwise. So if let's say I want my answer to be in clockwise, so 5 plus 2, 7 Newton meter clockwise. Okay, so this is my final answer for question 29. Okay, you can ignore the last part here, yeah? Parallel forces and couples. We will not cover in this course.